electricity, right, when we plug something into the wall socket, or static electricity, like I shocked Chris when he handed me something earlier.
Shocking.
So whether it's electricity like we use through the wall, or whether it's static electricity, you know electricity is caused by moving what?
Electrons.
Electrons.
Good answer.
So electricity, moving electrons. Electrons have what kind of charge?
Negative.
Negative charge. Okay, so electrons are negatively charged. You know the atom is made of a nucleus that's made of protons and neutrons. And the nucleus of an atom pretty much stays put in anything that's solid, right? The electrons orbit, not like a planet that just orbits, but they orbit outside of the nucleus, and electrons, negatively charged subatomic particles, electrons, they can move. And especially in things like metals that conduct electricity, they can move far from their atom. They can trade around. Every electron in creation is identical to every other electron in creation. So atoms don't care which electron they have. They flow, and electricity indeed is the flow of electrons. The batteries that are powering my camera right now have a flow of electrons that exit one end of the battery, make the camera work, and then re-enter the other end of the battery. I can get electrons to flow from my hair. This balloon captures those electrons. I'll look ridiculous, I'm sure, in a minute, right? It's a perfect day for it. So I just stole some electrons from my hair, and I put them on the balloon. Now, what is my hair doing right now?
It's trying to follow the balloon.
Yes. And is it also staying apart from each other? Is it still like sticking up?
No. A little. Not much.
A little bit? When your hair sticks up, and maybe mine is too conditioned today or something, but when your hair sticks up, when it gets repelled, it's because electrons were stolen, so each hair has a slightly positive charge. So they're like charges, right? Every hair is positively charged, so every hair is repelling every other hair because they all have the same charge. You know that same charges repel, right? So I just packed a bunch of negative charges onto this balloon, right? A bunch of negative charges. I stole a lot of electrons. This balloon is an insulator, meaning that electrons don't flow well out of it. So when those electrons get trapped on the surface of this balloon, they're stuck there. They can't flow because insulators impede the flow of electrical current. Electrons can't move around, they're stuck there. Right? So I have a negatively charged balloon. I've stolen electrons out of my hair. So what do you think will happen here? What's happening to the balloon on the string? Kind of let it get stationary again. So my negatively charged balloon is doing what?
Repelling the balloon.
It's repelling this balloon. And can you see what else is happening? It might be hard to see. Let me see if I
It
can.
looks like the white balloon is turning.
It's turning. And the white balloon is trying desperately to get to me to steal some electrons. I need to find a pen that works. And I'm going to try to put a mark. Okay, so there's a mark on one side of the balloon now. Let's see where that mark is naturally going to land if I get away from it and stop attracting it. So why did I move away to stop attracting it? Just like gravity decreases with radius, the electromagnetic force decreases with radius. So it doesn't notice me if I'm further away. If I charge up my balloon, I start bringing it nearer, we can see which side of the balloon is kind of charged. So you can see the balloon just spun all the way around, right? So why do you think that is?
Because all of the electrons moved away because it's already negatively charged.
And it is hard for electrons to move on the surface of a balloon because it's an insulator. That blue dot gets near me every time. I wonder if I can. So what I think is there's a concentration of electrons already on this side of the balloon.
Probably
And-
where you rubbed your head.
Yeah, and where it has stuck to me and stuff. So I really think it's going to always make the blue dot face the balloon. Yeah, because there's electrons. Oh, now they've evened out. So I can ground it actually by taking off my shoes. And your lab sheet says you should take off your shoes to ground things because electrons can't really flow through most shoes because they're rubber bottomed. So hopefully I'm discharging these guys, although it doesn't appear to be the case. So we have a lot of electrostatic attraction and repulsion here, is the point. We can see that negative charges, where lots of electrons are concentrated, repel each other, and a negative charge will be attracted to a positively charged thing. Like one side of that balloon, the side with the blue dot, oh, I'm all charged up now too. So which side of the balloon likes me? Ooh, the other side, not the blue dot side. So what charge do you think I have right now?
Positive.
So I think I'm positively charged. It's really hard to get something positively charged. So that's actually really nice. The only other way I know to do it is to get Scotch tape, because when you stick it to a table and you rip it off, the stickiness left behind on the table is the side of me.
You want to make it positive?
Yeah, it'll leave electrons stuck in the sticky stuff, so the tape will have fewer electrons than it ought to when you rip it off, and then it'll be positive. But we don't need to do that because I am clearly positively charged. So I attract the non-blue side of the balloon, and this negatively charged balloon attracts the blue side of the balloon, or makes it spin around until it figures it out. So fun. All right. I'm going to pull this down just so it's not so distracting.
I think you tied it up there.
Thanks, Clay. We've had enough lab apparatus fail today. We really didn't need another one, so that's good that it's secure. Okay, everyone's going to need a balloon and one of these little guys and an electroscope paper. And you need to be in groups of 3.
Miss Matthias.
Yes.
I've done this experiment on him before already. For my brother when he did this curriculum.
You can do
Good.
So,
Two groups of 2.
like, switch in place.
Okay, so let's see. 3.
Should I turn this off?
Everyone make sure that you have an electroscope that you're part of a group of, and you are not more than 3 to an electroscope.
Who's usually like see
All right.
people?
And every group will need to
Wait. Oh, these three. This group. Yes.
What group are you in?
I don't care. You can be in my group.
You'll be in that group.
Actually, it might work out more for you because you can just put it right in that corner so everyone can get to it, but this is more spread out.
Wow. Alright, so it's just you
You switch to. I guess so.
Okay. So I'm here.
Are you ready for this?
Yeah. Ooh, hard one. Are we? Or are you?
Okay, those are yours. So, when I give you
Hey,
foil,
Ryan, guess what?
here's what you're going to do.
I
You'll get 2
photocopied this.
little pieces of foil that you want to kind of smooth out to be as nice and straight as they can be. And then you take your electroscope and you hang 1 little foil on each little hook. And we have plenty of foil, so if you mess up, don't panic.
So we're gonna hang it.
Yes.
So we hang 1 little foil on each little hook. And you want it to have a hole that's just slightly bigger than it needs to be, so the foil can just like flop around easily and move easily. And then you'll do that. So you press those, cutting foil for each electroscope. You'll put 1 foil on each So smooth your foil and then
Smooth it out.
I know. I do that every time I touch an electroscope.
Like the weakest.
That's my fingerprint.
That one might be too wide. Tell me if you are having trouble with trim. Actually, let's trim them now and
I fell the tree.
trouble altogether.
What happens if a piece of the foil falls off? Will it still work?
What happened?
Oh no.
Oh, okay. So you want to hang it from the very tip, and I'll get you
Do
a new
I
piece.
hang it? Do I stab it?
Yeah, you basically want to stab it.
Nice job, Vanya.
Yeah, these things happen. Yep. So you want to hang it from one hook. Yep, and then you'll hang yours from the other. And then
This is Matthias.
grammar.
We need this. Our lectures.
Anyone need more foil?
So actually, I just sewed it.
You stab it.
Patrick, our
I'll just put out
lectures.
oranges.
Extra long.
No, we don't want extra long. Extra hard to control.
One would be good.
Extra long is not always extra good.
Aren't we all gonna get no fun without balloons? Let's put it in our calculator. Watch this. It gets 1 every time.
No, they're gonna separate themselves.
So, then each group will need, I'm going to make myself a little hoop even though I don't
And
have a
then
full electroscope. just
Actually,
we
so
can
it
kind
gets
of
down
talk about
and it
it.
rounds. So this.
So,
Oh no, wrong thing. Sorry. There.
alright, some groups can use
See,
balloons.
it keeps getting slightly lower, but since it's such a small depression, they had to make it 1 for every time. So then, see, as soon as it gets past, see, as soon as it gets past 5,
If you have hair product, you may not want to be the person that rubs your head because hair product is not awesome for conducting electricity.
I used water. All you do is use water. Yeah. That's just like you might as well just pour water all over you. Just go like, oh, I washed my hair. No. To like fix my hair. Oh, yeah. This poor camera, it's recording.
Oh my gosh.
Sad.
It's okay, camera. It'll be fine. Okay. I think you did it enough.
Is it good?
You might need to do it faster.
Yeah, it's good.
Is it good?
Yeah, Joseph is fine.
Here's like this.
My book because my mom's gonna sell it again.
See what-
Oh, look at that. Except that magic book.
Alright, so clearly you all have started to see kind of what the electroscope does. Where did I lay my There it is. Okay. Alright, so grab your lab sheet for today. And we'll start on number 1 and kind of work through it together.
No, that's not an experiment.
So, part 1, electrons on the move. Everyone take off your shoes. So if you're the person like...
Take off my shoes. I don't want to take off my shoes. I'm not taking off my shoes.
I'm sorry. My
If
shoes
your
are personal.
experiment's not working well, you'll probably have to take your shoes off. That usually fixes problems. Okay, so build the apparatus and get it checked. Once your foils are hanging, you want to draw a diagram of the apparatus and label the parts.
I don't want to do this.
So everyone draw a diagram of your electroscope.
It's the third.
It'll be fine.
December.
What?
Another business.
No, don't let it. Don't let it run away.
I have to make it super detailed.
Yeah, don't include too much detail. It's fun.
I didn't want to take off my. I don't want to take off
Is
my
this copper?
shoes.
Yes. Some of your wires are
Does
paper
this
clips
count?
and some of your wires are copper. Okay.
I said pepper and I said copper.
And it's probably
Does this count as taking your shoes off?
It's called aluminum. Yeah.
and you can just write foil
Use.
You can just write foil if you want to. Hey, you just write foil.
Foil.
It might be easier than writing aluminum. Foil.
Aluminum.
You just write foil.
Aluminum.
Yeah, foil is fine.
Alumni.
People saying
That's really all you need to label.
and the balloon.
So once you've drawn, oh yeah, we can.
I'm done with
I didn't
playground.
draw the
This one
balloon,
should shock
but
the
that
whole
is definitely an important part of your apparatus.
In the summer when you run around on playground, you touch stuff and you get shocked. Whatever you do, don't touch me.
It's the worst part
Your
of the
balloon or
It will shock
electron
me.
source.
Never die.
And if you draw someone with their hair sticking up, that's fine too. But do it later because you need to keep up now. Okay, so you've got your electroscope. It has a loop of metal, whether it's made of copper or paper clip, you have a loop of metal. And then it has little hooks on the end with aluminum foils dangling down. You've got a plastic lid and a glass beaker, right, and a balloon. So number 2 says, which of our materials are insulators? Things that don't allow electrons to flow.
The lid and
Okay,
the
glass.
lid in the jar.
Alright, so our insulators would be the plastic lid, the glass beaker, and I don't know, balloons are probably latex, plastic, kind of, and a balloon. Alright, so we've got our conductor, our insulators. Which of the materials that you have in your electroscope are conductors, Chris?
Foil?
The foil is a conductor, it's aluminum, which is a metal.
There's a way to clean up your hair. Take it
And what else?
In the wire.
Okay, so whatever your loop is made of is going to be a conductor, whether it's copper loop or a paper clip, some kind of metal. So your loop and your foils are made of metals, and those are good conductors. They allow electrons to flow easily around in them. So electrons, this is like the third line of number 2. Electrons can flow through conductors, and electrons do what? Because their charges are what?
The electron negative.
Okay, so all electrons have a negative charge, so their charges are all alike, so they do what to each other? Repel each other. All electrons repel other electrons because their charges are alike. Electrons repel other electrons because their charges are alike. Right, they're both negative. Every electron is negatively charged. A negative will repel a negative. A positive will repel a positive. The only things that attract are things with opposite charges. Don't pop your balloon. So number 3 says, rub your balloon in your hair, which clearly no one has been able to resist. What do you observe?
It's sticking through her hair.
If you haven't done it, okay, if you want to look at Bethany, that's a dramatic situation over there. Joseph clearly has something going on over there. So what do you observe when you rub that balloon in your hair?
It's sticking to my head.
Okay, the balloon
It is
becomes
attracted to
to some stuff.
someone.
Now, when I had the other balloon up here, the balloon was also repelled by some stuff, right?
You had a positive charge.
Right, I got
No, so you had a
positive.
negative charge if it was repelling.
Well, the balloon had one side that was negative and one side that was positive.
It was both.
So I think I was positively charged because the negative balloon was attracting the blue side dot of the balloon. When I did it, I was attracting the non-blue dotted
negative?
side. So I think I was positive, and the blue dotted side was positive. I was repelling the blue dot and attracting the non-blue dot, which is confusing, but so clearly you're having some kind of attractive forces and repulsive forces when you've rubbed that balloon in your hair. So what has actually happened when you've rubbed that balloon in your hair?
You're picking up electrons.
So is your hair gaining electrons or losing electrons?
Losing.
Your hair is losing electrons. Is the balloon gaining or losing?
Gaining.
The balloon is gaining electrons. So what kind of charge will the balloon have when you've rubbed it in your hair? The balloon, especially the side that actually touched your hair, is massively negatively charged. Okay, so the balloon is getting a negative charge. Electrons are stolen by the balloon from the hair. So number 3, the balloon gets a negative charge. my markers are all not working. If I write big with a weak marker, balloon gets a negative charge.
There might be some markers in the
It gains electrons. Ooh, it's getting better. If I write really tipped up like this. Alright, the balloon gains electrons. At the end of number 3, does the balloon develop a positive or negative charge when you rub it on your hair?
Negative.
Negative charge. Does the balloon develop a positive or negative charge when you rub it on your hair? It's negative. So that little blank at the end of number 3, negative. So now we start with the electroscope. There are 3 things that we're going to do with the electroscope. So I really want you to kind of break this in your mind into 3 parts. The first part is this, okay? You're going to rub that balloon on your hair, or I will, and then you're going to bring it near your loop, but not touch your loop. All right, so now before you bring it near, look at your foil, and then look at your foils while you're bringing it near and see what your foils do.
When you bring them back,
So look at your foil.
Give me the thing. Give me the balloon. Give me the balloon. No, I'm not gonna pop it.
how do the foils look?
The foils like don't
Avoiding each other. They didn't do very much.
They're kind of like
Put it this way, then they
Put it
kind
near
of
it.
swing like this.
bring it near.
It's
I guess
separated.
they're separated.
Because you touched it, I think. I can't discharge it.
Just look, this is what I did to this picture. Because this is, I just put my hand around it.
That's weird. My hair is defying gravity.
They separate from each other.
Right, but as long as you don't touch it, they should.
Okay,
I don't know.
so has everyone made an observation of your foils?
Nothing.
All right. When you bring the negatively charged balloon near the foils, what do you observe? They move apart or together?
Apart.
Slightly apart.
So they move apart. The first Lincoln number foil, the foils repel. The foils move apart. Yeah, they move apart. So why do you think they do that? Oh wait, we talk about that later. I will keep in order. Foils repel. The second Lincoln number foil says pull the balloon back away. What happens?
Pardon, you move back when they go back.
Right, they go back to the way they used to be. So, second blanket number 4. You pull the balloon away, the foils go just back to the way they used to be, except apparently yours. So, let me get that on camera because it's boring to look at me.
Oh, you're kind of stabbed in.
Okay, so we want to like kind of straighten. Not that. All right, so.
I don't want to freak people out in a Halloween place. Just do
You're
this with your
so,
hair.
it's so staticky today. It like nothing will like stop being charged, and I think I'm all charged up anyway.
When it snowed, it was super dry. Whenever I touched anything,
Yeah, it messes it up. Okay, I think we're good now. So bring your negatively charged balloon near your foils for the camera.
It's definitely
Joseph.
Oh,
you gotta get it off your head someday.
this.
Yes, bring negative balloon near foils, and foils move apart. It's really hard to see. Go ahead. All right, we can see them moving apart a little bit, and then move the balloon away.
What are the first couple?
Oh, you guys are so charged up.
I mean, I go bend.
My hair is definitely moving.
I think it's just
Well,
It
that's
didn't
aim.
move like that before.
because I touched it.
All right, pull it away.
And if you
Put
move
it together toward.
They move closer together.
Oh, nope, not in the room. Back apart. Wait, what?
They're going together. You pull them away.
and if you move it this way, then they're attracted to the balloon. Oh my god!
So-
Just try to pick up your paper.
Because I touched it. And
Yeah.
they said if you touch it, something will happen.
All right. Try again. Balloon comes near.
You shouldn't go closer
yeah.
together.
You guys are seeing it. Oh my goodness. Like, I don't even need a balloon when I come near this electroscope. It's me. I'm like so charged that when I come near your experiments, it's messing them up. Hold on. I'm just going to put the camera down and back away here. I don't want to touch your electroscope, but move it, well, here.
Hey, his is working.
Whose is?
Like his. They worked. They separated and went together again.
All right.
It's really
So when you bring the balloon near, they go apart. When you take the balloon away, they go back together. So
Now
now,
we're going together.
some electrons must have jumped the gap. That's. It's just really, really staticky and dry and wintry. Touch with your hand on the foil. Okay. All right. Discharge your electroscope by any means you have to.
Do I just touch it?
Just touching it should work. Your electroscope should not have gained a real charge. So let's talk about what really should have happened here. And what you saw happening at the beginning of the experiment was good. What you're seeing happening now, not so great. Where did I leave?
Here, do it again. Finish it.
All right,
Yes, he does.
Right. So put your electroscope back together. Okay, now everyone listen. Okay. So, ideally, here's what should happen. You bring the balloon near, the foils go apart. You pull the balloon away, the foils go back together. Apart, together, apart, together. Just like that, right? So, where do the electrons from the balloon go? Is that aimed okay? If it's not hitting. Okay. Where do the electrons from the balloon go?
They go into the foil.
Do they go anywhere?
No.
The air is also another insulator. The air is another insulator. Air. My marker is completely failing at this point. Air is another insulator. Air, I promise. So electrons aren't actually moving from the balloon to the foil. So why does the balloon have an effect on the foil if no electrons are moving from one to the other?
Wait, can you ask? What was that question?
Okay, so where do the electrons from the balloon go?
Nowhere.
Nowhere. They stay on the balloon. The balloon's an insulator and it doesn't touch anything. Okay, so the electrons just stay on the balloon. So what charge does the whole electroscope, the foils and the loop, what kind of overall charge does it develop?
Positive.
No charge. So here's where I have to give you the answer. This is kind of the hard part. Electrons move around in your loop and in your foil, but no electrons leave the loop and foil, and no electrons come onto the loop and foil because the loop and foil are surrounded by an insulator, the air's an insulator, the balloon's an insulator. No electrons are actually going from one object to another. They're just moving around in the loop and foil. So, touche.
So all the electrons go down to the foil.
Exactly.
And they repel because they're
Right. So you've got the loop here. That big negative charge comes and sits here. And every negative electron in the loop goes, ah, and gets repelled. And the furthest they can get from the balloon is the foils. So they all go down there. So both foils get all these fleeing refugee electrons.
Refugee.
Right. The refugee electrons hang out in the foils. So the foils develop what kind of charge?
Negative.
Negative. All right. So the foils get a negative charge. They're both negative, so they repel each other. But when the balloon goes away, all those electrons just go back up to the loop, and nothing has really changed. Duchesne.
So if this was a thinner wire, would this repel it also? Like if it could actually move?
If it could move, no, because the electrons